When a cooling tower is in service, it's important to check it for proper operation. As an operator, there are several routine checks that you can make to ensure that the tower is operating properly. One thing to check is the water level in the catch basin. If the level is too low, the circulating pump could lose suction. That could damage the pump and reduce or stop the flow of circulating water. The level in the catch basin is sensed by floats in the basin. Operators should check the floats to make sure they move freely so that the proper level can be maintained in the basin. All cooling water contains contaminants. The contaminants in cooling water can be divided into four broad groups: suspended solids, dissolved gases, and microorganisms. Suspended solids are solid particles that are trapped in the cooling water. One source of these particles is air. Dust and dirt can be carried into the tower by the air passing through it. These particles become trapped or suspended in the cascading water. Another source of suspended solids is the makeup water. Solids are carried into the tower as water is replaced. When suspended solids collect inside a cooling water system, they form a thick mixture called sludge. Sludge can restrict water flow through equipment, interfere with the transfer of heat, and decrease cooling tower efficiency. Chemicals such as calcium or magnesium are often found as dissolved solids in cooling water. These impurities can become concentrated, come out of solution, and cause scale buildup. Scale buildup on the inside of a heat exchanger can reduce heat transfer and restrict water flow. Now, there are several ways that dissolved solids can concentrate to form scale. For example, when water evaporates in a cooling tower, solids are left behind, and the concentration of solids becomes higher in the remaining water. Also, untreated makeup water may have high concentrations of dissolved solids. One way to control the concentration of solids in a cooling tower is to drain or blow down water from the system. A blowdown is an intentional discharge of cooling water from the catch basin. In addition to blowdown, scale-preventing chemicals may be added to the cooling water to control scale buildup. These chemicals, known as scale inhibitors, form a protective layer on metal surfaces that prevents scale from building up. Other chemicals may be added to control the water's pH. The water's pH is an indication of its acidity or alkalinity. A low pH means the water is acidic. A high pH means the water is alkaline. A relatively low pH tends to increase the likelihood of corrosion, while a relatively high pH tends to increase the likelihood of scale formation. If the water's pH is high, acids such as sulfuric acid, which have a low pH, can be added to lower the water's pH. On the other hand, if the pH is too low, an alkali is added to raise the water's pH. Cooling water is often sampled and tested for solids concentration and pH. The results of the tests determine how often blowdown should be done, how much water should be blown down, and the amounts and types of chemicals that should be added. Another group of contaminants that you should be aware of is dissolved gases. Cooling water often contains dissolved gases such as carbon dioxide, hydrogen sulfide, and oxygen. Some of these gases can react with the metal in the cooling system to cause or speed up corrosion. Large amounts of some dissolved gases tend to make the water acidic, giving it a low pH. At a lower pH, corrosion is more likely to occur. To counter the effects of dissolved gases, corrosion inhibitors such as lime are often added to interfere with the corrosion process or increase the water's pH. Your cooling system may have specific operating requirements for pH. These requirements will strike a balance between a high pH that will reduce the rate of corrosion and a low pH that will reduce the rate of scale formation. Microorganisms are very small plants and animals, such as algae and bacteria. Air and sunlight stimulate microorganism growth, so cooling towers make good breeding grounds. Microorganisms often create thick, gummy slime growths that can foul tubes and heat exchangers and reduce the amount of heat that can be transferred. Another problem with microorganisms is that they can release gases such as oxygen inside cooling systems. This can promote corrosion of the equipment in the system. Microorganisms can be controlled by adding chemicals called biocides. Chlorine is one biocide that's commonly added to water to prevent slime growths. Chemicals are added to the water in cooling towers for many reasons. You may be responsible for adding chemicals to the water, so you need to know how to do it safely. Many of the chemicals used may be hazardous if they're not handled properly. You should always be aware of their specific hazards, and you should follow your company's procedures when you handle any chemical. The precautions you need to take may depend on how the chemicals are added. For example, some chemicals can be added so that there's no contact with personnel. Chemicals such as acids are added using chemical injection pumps like this one. On this pump, the amount of chemicals added can be controlled by adjusting the stroke of the pump. That's done by turning this knob on the pump's controller. Chemicals are sometimes added using specialized metering devices. Here, chlorine is added to the cooling water through this chlorinator. A chlorinator regulates the flow of chlorine gas to the cooling water system. The chlorinator allows chemicals to be added in such a way that personnel do not come into direct contact with the chemicals. Now, chemicals aren't always added with specialized equipment. Sometimes you have to add them by hand. If that's the case, you'll need to follow your company's procedures about where and how the chemicals should be added. For example, you may be required to add the chemicals near the makeup line so that they can be thoroughly mixed with the cooling water. Depending on the type of chemical that you work with, a face shield, rubber apron, gloves, and boots may be required to protect your body. In some situations, the chemicals being added may be in the form of a powder, so a dust mask or a respirator may be needed in addition to eye protection and other protective gear. Also, you should know the location of the nearest emergency shower and eye wash stations. In this topic, we looked at cooling water contaminants and their effects on a cooling water system. We also discussed why chemicals are added to cooling water, and we looked at how these chemicals can be added to the water. Now let's try some practice questions on this material.